Hey guys, welcome back. We're going to do another couple of problems, 2017, 2018 on graph analysis FRQ in preparation for the AP exam, okay? So it says the function f is differentiable on the closed interval between -6 and 5 and satisfies the initial condition here. The graph of f prime, the derivative of f, consists of a semicircle, that's important, and 3 line segments as shown in the figure above. Okay. Here it is. And guys, a lot of times, I think 99% of the time, they're going to give you the derivative, okay? Because that's what they're asking to analyze. Find the absolute minimum value of f on the closed interval, okay? But let's go ahead and start part A. I'm getting ahead of myself here. 3 line segments, okay, part A. So part A normally should be the easiest, okay? And let's see, find the values of f of -6. Okay, well, all right, so how am I going to find f of -6? What do they give me? They give you f prime. So how do I find f from f prime? That's right, you're going to take the antiderivative of the f prime. Okay, good. Well, where do I go from? From where to where? What's your initial condition? -2 to where? What are they asking for? -6. Okay, there it is. Now what do? I do my fundamental theorem. Top minus the bottom, and then I have to solve for f of -6. So remember, this guy, I'm going to bring him over to the left. So f of -6 is going to equal, this guy becomes a positive, so it becomes f of -2, and then plus we have this integral from -2 to -6 of f prime of x dx. Now the only thing is I don't like it goes from -2 to -6, so I always like to put the smaller value on the bottom for the limits, because if you think about it, right, if you would go from -2 to -6, you're going backwards. I don't want to go backwards. I always like going from left to right. Well, my initial condition, I'll just put it here, f of -2 first, minus reverse the limits of integration. I would want to put the lower limit first on the bottom, f prime of x dx. And we're finding f of -6. Okay. F of -2, they already tell me the initial condition is 7. So that helps me out. 7 minus, okay. Now I need the integral from -6 to -2. Well, how do I find that? Well, look at, they give me the what? The graph of what? F prime. So remember, the integral is the area underneath the curve. So we're going to go from -6 to -2. And we're going to find the area of this shape right here, which is a triangle. Okay, so you go down 2 and you go to the right 4. So 2 times 4 is 8. Half of 8 is 4. Okay, now remember, because it is above the x-axis, the area, okay, it's positive. So then 7 minus 4 is 3. Okay, and actually I shouldn't say the area. The area is always positive. The integral is positive because it's above the x-axis. Okay, so boom, we got it. F of -6. So now I have to do the same thing for f of 5. So all right, so let's do it. F of 5, and let me go ahead and do this. So what do I have to do? I also have to do the antiderivative, f prime of x dx, from where? What's my initial condition? From -2 to what? What do they want us to find? 5. All right. Do my antiderivative, that becomes f of 5 minus f of -2. What do I have to solve for? I have to solve for f of 5. All right, and that's going to equal, remember, take this guy to the left, becomes a positive. So we're left with f of -2 plus the integral from -2 to 5 of f prime of x dx. Cool. All right, well, it's f of -2. My initial condition is 7. All right, plus... Now from -2 to 5, from -2 to 5, we have that two things. We have this semicircle, and then we have this triangle. Now, remember, this is a semicircle, so it's pi r squared, and it's a semicircle. So we'll see, radius is 2. So it's going to be pi, radius is 2 squared, divided by 2. Why divided by 2? Because remember, it's half of a circle, semicircle. And this guy here underneath, the area is going to, I'm sorry, not the area, the integral is going to be negative. Okay, negative. Okay. And then plus, well, why plus? Because look it, I'm going to find the area of this triangle is going to be above the x-axis. So the integral is going to be positive. So this is a triangle. So 1, 2, 3. 3 times 2 is 6. Half of 6 is 3. So that's going to be a positive 3. So the integral is a positive 3. It's right there. Boom. So when we go ahead and do this, okay, 2 squared is 4. 4 divided by 2 is 2. Okay, so this becomes negative 2 pi. And then 7 plus 3 is 10. So 10 minus 2 pi. And that's it. And actually, I mean, even if you leave it like this, I think they would give you the correct answer. But we're going to be using this value later on. So it's not too bad. I mean, just be careful. And take your time. Don't rush. All right. But hopefully that makes sense. Remember, the goal is to understand how to get to where we're understanding what they're asking for. Okay, so let's go ahead and do part B. All right, part B, it says, on what intervals is f increasing? Now remember, we talked about increasing, decreasing. That's talking about the first derivative. So what does that mean? They give us the graph of what? The first derivative. So remember, all of these are slopes that are connected by a smooth line right here. See, all of these are slopes. These are all positive slopes. How do I know they're positive? Because they're above the x-axis. So when the slopes are positive, okay, that means the graph is going up. Right here, the slopes are negative. That means the graph is going down. And right here, again, the slopes are positive. Okay, the slopes are positive, so the graph is going up. Well, what happens here? The slope, right? The derivative is equal to 0. You have a horizontal tangent. Derivative is 0, horizontal tangent. Okay, and that's where it changes from increasing to decreasing. So where is f increasing? Here and here. So it goes from negative 6 to negative 2, negative 6 to negative 2, and from 2 to, what is that, 5? Yeah, from 2 to 5. Okay, and that's it. Well, how would you answer this question on the test? You would say f is increasing on this. You would put this. Why? Because, okay, f prime of x is positive. You would just put that. That means positive. That's it. That's all you got to do, guys. And that should give you all the points, which is actually just 2 points. But not too bad. Pretty simple. I thought part A, actually, believe it or not, part A is 3 points. And it's understandable why there's a lot of work. But hopefully it makes sense, right? How do I get f from f prime? The antiderivative. And then you just go step by step. Step by step. Okay, so that's part B. Let's go ahead and do part C over here. It says find the absolute minimum what? Value. You see that? The value of f on the closed interval from negative 6 to 5. Okay. So now, when I see minimum, maximum, I'm already thinking first derivative, set it equal to 0, find my critical points, do the number line. And that's just, hopefully, that's what your teachers also taught you. So where do we have our critical points? When the first derivative, okay, is equal to 0. Well, this is my first derivative. Where is it equal to 0? Well, it's equal to 0 right here, and right here. If you want, make a number line. Okay, let's go ahead and make a number line right here. Boom. Okay, and what are my critical points? Negative 2, positive 2, and what is that? 5. Okay, cool. And then you just, what's happening? So where would we plug it into? We would plug it into the first derivative, right? F prime. Hey, this is f prime. So to the left of negative 2, what happens? The derivatives are what? They're positive. And after that, they're what? They're negative. And then after positive 2, they're what? Positive. And what about after 5? Well, we don't know. So it goes up, it goes down, it goes up. So here we would have a max. Here, right, at 2, you would have a minimum. Okay, boom, at x equals 2, you have a minimum. But what do you need? They're asking you for the minimum what? Value. When they're asking you for that value, guys, you're going to have to find not only the middle, your critical point, right, at 2, you're also going to have to find the beginning and the end. What's the beginning of our interval? Negative 6. And you're also going to have to find positive 5. Okay? You have to find those values. Okay, well, how do I find negative 6? Oh, you know what? We actually did already. Negative 6 is 3. f of 5, we found it also, is what? 10 minus 2 pi. Okay, now I just have to do f of 2. Okay, well, how do I do that? Remember, okay, how do I get f from f prime? You do the antiderivative of f prime. Okay, from where to where? Well, what's your initial condition? Negative 2. To what? Well, what are you trying to find out? Positive 2. And now I do my fundamental theorem. F of 2 minus f of negative 2. I got to solve for f of 2. All right, so rearrange that guy. F of 2 is equal to, bring this guy to the left, becomes a positive f of negative 2 plus the integral from negative 2 to positive 2 out of f prime of x dx. Okay, f of negative 2 I know is 7 plus, okay, now we're talking from negative 2 to 2. And you notice, right, the semicircle is below the x-axis. And we already solved, I think, the area for that guy. What is it? 2 pi. All right. It's actually negative 2 pi, right? But we'll just go ahead and do it. So it's pi. The radius is 2, is squared. We're going to take half of it because it's a semicircle. And it's actually negative. Why is it negative? Why? Because it is below the x-axis. The integral is negative. Area is not negative. So be careful with that. Okay. The integral is negative. So this becomes 7 minus, this becomes 2 pi. So this is 7 minus 2 pi. So where is the lowest value? Okay, it's going to be where? Right there. Okay, at f of 2. And there it is, guys. That's it. All right. Last part, part D. Okay. It says for each of f double prime of negative 5. Okay. We'll put D right there. And f double prime of 3, find the value or explain why it does not exist. Okay, so remember, second derivative. What do they give me? They give me the first derivative. Okay, so how do I find second derivative? From this guy, I'm actually going to have to look at the graph and analyze the slope. So at x equals negative 5, 1, 2, 3, 4, right here. Okay, I have to look at the slope because this is the first derivative. I have to look at the slope. Oh, look at the slope of this line. What's the slope of this line? Okay, you just do your algebra on y2 minus y1 or f of b minus f of a. So if you notice, you go down 2 and to the right 4. So it's negative 1/2. So what you want to go ahead and do is f double prime of negative 5. Just go ahead and let them see it, right? This is the point 0, negative 2 comma 0. So you would want to go ahead and do 0 minus 2 over negative 2 minus negative 6. And that's going to equal negative 1/2. Okay. And that's it. That's it. Okay. The second derivative. Okay. And then it says find the value. We found it. I don't have to give any reason. But now let's do the same thing for f double prime of 3. All right. Here's 1, 2, here's 3. What do you notice? It's a cusp, right? It's a jagged edge. We cannot take the derivative there. Okay, so you would say f double prime of 3 dne does not exist. I think they might understand that, but I think it's better just to write it out. Just just not to leave anything, so that they don't know. But remember, these are teachers. These are human beings, so they want to give you the points. But so it does not exist. Why doesn't it exist? Okay, now the real reason is because the limit from the left of f prime of x does not equal the limit from the right. Remember, that's a fundamental definition of the derivative. The limit from the left has to equal the limit from the right. Same thing when we're talking about differentiability. So how would you write that? Okay, you would write because the limit as x approaches 3 from the left of f prime of x does not equal the limit as x approaches 3 from the right of f prime of x. And that should be plenty enough, okay? And they'll understand that verbiage, all right? And that's it, guys. That's it. Let's go ahead and take a look at 2018. But if you notice, they're asking the same type of problem, the same type of things, okay? So let's go ahead and do 2018. They give you another graph. Hopefully it fits here. The graph of the continuous function g, the derivative, you see, this is the derivative, except I noticed now in 2018, they didn't call it f, they call it g. It's okay. The graph of the continuous function g, the derivative of f, is shown above. The function g is a piecewise linear for -5 to 3. So from -5 to 3, it's a piecewise. And then it becomes this quadratic function from 3 to 6. So you notice how they did that? They combined a piecewise, right, with a quadratic, right? And they told you, all right, so all of this is the derivative. Interesting. If f of 1, your initial condition, what is the value of f of -5? Does that sound familiar? Yeah, it does, right? So what do they give me? The derivative. How do I find the derivative? How do I find the f from the derivative? You guessed it, the antiderivative. So we're going to do the antiderivative of what? Of g. Okay? Because they tell me, look at the derivative g is the derivative of f. So we'll just, hopefully you don't get confused. Where are we going from? Well, what's your initial condition? Right here, 1. 1 to what? Not 3, I'm sorry. 1 to what do they want you to find out? -5. -5. Right there. And then what do? You just do your fundamental theorem. All right? Now, normally I would do g, but because it says that the antiderivative is f, so I'm going to use f. F of what? F of -5 minus f of 1. And then I have to rearrange that. Okay, so what do? Well, you got to solve for this guy, and I'll just go ahead and do it up here, guys. F of -5 is equal to, this guy goes to the left, becomes a positive, f of 1 plus the integral from 1 to -5 of f, g of x dx. Okay, there it is. The only problem is I always like to have the lower limit of integration at the bottom. So I'm going to put f of 1 minus, reverse the limits from -5 to +1 of g of x dx. All right, so let's see if I can fit it in here. F of -5, what's my initial condition? F of 1 is 3. Minus, let's see what we get here. Now from -5 to 1. Okay, so from -5 to 1. All right, let's see here. So from -5 to 1. I have a trapezoid, huh? I don't like to do trapezoid. I'm just going to do basic. I'm just going to cut it up into a rectangle. And I'm on a square and a triangle. So 1, 2, 3, 1, 2, 3. So 3 times 3 is 9. Cool, but because it's beneath, okay, it's going to be a negative. So you have -9, okay? And then this guy here is 1 times 1, 2, 3. Well, 1 times 3 is 3. Half of 3 is 3/2. There it is. Okay, so this guy doesn't fit enough to write it in there. Now remember, why did I put -9? Because it's below the x-axis. Why did I put -3/2? Because it's below the x-axis, okay? So the integral is going to be negative, all right? All right, and then we're going from -5 to, you know what? We're going to 1, huh? And I almost made that mistake. So I saw that 1 and I thought, oh, it's just -1. No, we actually got to find this guy up here too. So, and then this guy is what? 1 times 1, 2. So 1 times 2 is 2. Okay. 1 times 2 is 2. And then half of 2 is 1. So actually, I forgot over here. Okay. And then what am I going to do? I'm going to add 1. Why am I adding 1? Well, because this guy's above the x-axis, okay? So the integral would be, the area under the curve would be positive right here, okay? All right, so now, actually you can leave it like this. I think they would give you all the points, but let's just go ahead and do it. And if you do it correctly, guys, you should get 25/2. I mean, they're gonna allow you to use a calculator, so just, leave it there. Yeah. But we might use this later on, so you might have to simplify it, but not too difficult. All right, let's go ahead and evaluate the integral from 1 to 6 of gx dx. Cool. All right, that means they give me the antiderivative, right? So what do I have to do? I have to do the what? Area underneath the curve, okay? So from 1 to 6, all right, so that means I have to go from here to here. So let's see here. That means, well, I know the area underneath the curve. I can do this, right? And I can do 2 times 2 is 4. But then look at this. How am I going to solve the area here? Because it's all curved. How do I find the area? And look at, that's when you go to this guy. You see, remember, they give you a piecewise from -5 to 3, but from 3 to 6, we're supposed to use what? This quadratic here. So what you're going to go ahead and do, let's go ahead and put it down here. So the integral from 1 to 6 of gx dx, okay, we're going to separate it. Yeah, let's just separate it from 1 to 3 of g of x dx plus the integral from 3 to 6 of g of x. What's g of x? That's this guy, 2 times x minus 4 squared dx. Now we figure out the area here. That's going to be 4, and that's easy. Plus, now what do I have to do here? There you go. You guessed it, right? You're going to have to do your antiderivative. Now there's a couple ways to do it. I'm going to do it the long way. Okay, hopefully just maybe some people, some of you are struggling with this, but I'll go ahead and do it the long way, and it's not too bad. Let u is equal to x minus 4. That means du is equal to dx. Okay, that means we're going to have the integral, all right, 2, and then u squared, and then dx is du. And let's change our limits of integration. You plug in 3 here. 3 take away 4 is -1. Plug in 6. 6 take away 4 is 2. Okay, so you have 4 plus, remember we haven't done the antiderivative yet, so you add 1 becomes a 3 and divided by 3, and then we're going to go from -1 to 2. All right, so let's go ahead and do that. That's going to give you 4 plus, so let's go ahead and plug it in. Write it, okay? Don't do too much in your head just yet. Once it's written inside, then you can go ahead and start doing the stuff in your head, mental math. So top minus bottom, so be careful with that, okay, guys? Minus, and then on the bottom is -1, so that's minus, and then we have to do it again. Plug in the -1 to the third, and that's cubed. Close it off with my brackets, okay? So now, let's see here. Let's do some mental math. 2 cubed is 8. 8 times 2 is 16. 16 thirds. All right, 16 thirds minus. -1 cubed is -1. -1 times 2 is -2. So this is -2 thirds times another negative. That becomes +2 thirds. Okay. Positive 2 thirds. Right? And then we have the plus 4 here on the outside. Okay. So that becomes 4 plus 18 thirds. And I would just leave it like that. That's perfectly acceptable. Okay. And that's the integral. But if you want to go ahead and continue to simplify, the answer you should get is 10. Okay. But this, if you leave 4 plus 18 thirds, that's perfectly acceptable. They're not, they're not testing your, arithmetic. They're testing your calculus. Okay. And besides, the test is timed. All right, that's part A, part B, now part C. Okay, let's go ahead and do part C. It says for the open interval between -5 and 6, is the graph of f, it says on what open interval, is the graph both increasing and concave up? Haven't they asked this same question over and over again over the past years? Absolutely. See, so hopefully now you're starting to see it. All right, remember, increasing, decreasing, we're talking about first derivative. Concavity, we're talking about second derivative. So remember, when we're talking about increasing, decreasing, remember, the graph of f is increasing here. Why here? Because the slopes are positive. Over here, the graph is what? Decreasing, because the slopes are negative right here. So now, where is it increasing? Okay, so we're only looking at this section here. Boom. So now we're looking at concavity. Where did it concave up? Well, if you notice, look this. Check this out. From here to here, what's the graph doing? It's going up, huh? The slope is positive. It's going up. So that means here it's going to be concave up. Right here, it's what? 0. Nothing. Right here, what is it? Concave concave down. That's right. So right here, let me put concave down. And then up here is what? Concave up. So the question is, where is it both increasing and concave up? Well, it's concave up here, and it's concave up here. So you would write it is, let me see here, go from 0 to 1, and it would go from 4 to 6. 4 to 6. Okay. And that's it, guys. So how would you answer this question on the test? You would say, let me see here. The graph of f is both increasing and concave up on, and then you would put this. Okay. And that's it. Give a reason. Why? You would put f prime of x is positive. Okay. And then right here, f double prime of x is positive. And you're saying, well, is that enough? I mean, yes. Remember, they're human beings. They understand math, calculus. So when I see this as a teacher, first derivative, oh, they know what they're talking about on this interval. Oh, they know the second derivative is positive. They know what they're talking about. And that's it. If you want to put is, you know, it's increasing, and I mean, you can do that as well. That's perfectly fine. Okay. Increasing, and yeah, that's perfectly fine as well. But this, to me, is plenty enough. It's up to you guys. It's up to you guys. Okay. But sometimes some of us, you know, we have difficulty writing it out. But just use the graph. Look at use the same verbiage. The graph of f is both increasing and concave up on what? Here and here. Why? Because boom, first derivative is positive, second derivative. Okay. All right. And a lot of times it's sometimes it's arbitrary, but they go by strict guidelines on how to read it. So I think you should be fine. Part D. Okay. Find the x-coordinate of each point of inflection. You notice that? You notice that? Point of inflection. Now, point of inflection, haven't they asked that also in the previous years? Yes, they have, huh? Point of inflection, what are we talking about? We're talking about the second derivative. Okay, so find the x-coordinate for each point of inflection on the graph of f. Give a reason for your answer. Okay, now remember, second derivative. When does a point of inflection happen? Remember, the point of inflection happens when it changes concavity. Changes concavity. Make sure you put that in your notes. Changes concavity. All right, and actually we already did it. Now they're asking us, yeah, from the whole graph. Okay, so right here, what is that? Okay, well, the graph is neither increasing or decreasing, right? We're looking at the derivative. The derivative is 0. What happens here? The derivative is what? Is going up, right? The derivative is positive. So this would be concave up. Then what? The derivative is what? 0. Then the derivative is what? Up, positive. 0. Negative, so it's concave down. And then it goes what? Positive, concave up. So the only place where it changes concavity is here. Right here, guys. Right there. That's the only place it changes concavity. Okay, so how would you write this? Okay, you would say the x-coordinate of the point of inflection is at x equals 4. Why? Okay, and you would say because, you can say because f double prime of x, okay, changes from concave down to concave up. Okay, or you can say it changes from decreasing to decreasing at x equals 4. However you wanna say that. But hopefully you're starting to see, you know what? They're asking the same type of things from the graph. They give me the derivative. They tell me to find a value based on our initial condition. They're asking me to find the area underneath the curve. They're asking for increasing concavity. They're asking for point of inflection. Same fundamental things, guys. So hopefully this helps and you get more confident doing these, guys. All right, guys. See you guys next time.